of the three big theorems that you have, like the named theorems that we use a lot in calculus. One of those three you have already learned. What theorem have we already learned that had a name that we used quite a bit? Intermediate value theorem. I even snuck one of those in on that last test, right? Even though it technically is in an earlier unit. So intermediate value theorem is a theorem that we have learned. The next one is going to be mean value theorem. And the third big theorem that we know by name is extreme value theorem. It'll also be in Unit 5. We haven't gotten to it yet. So the mean value theorem states that if f is continuous on the closed interval from a to b and differentiable on the open interval from a to b, then there exists a number c in a, b such that f prime of c equals f of b minus f of a over b minus a. So let's draw ourselves a picture for what this means, okay? Okay, so we'll stick to the first quadrant just because pictures are easier to draw there. And we've got some sort of function that is continuous from a, so I'm going to put a here on my x-axis and b somewhere over here on my x-axis. It does not matter what the function looks like as long as this function is continuous. So I'm just going to draw in something like this. Okay, we're going to call that f of x. And this function must be continuous from a to b. It is. It also must be differentiable from a to b. So it doesn't have to be differentiable at the end point. So that's like a technicality you're not going to run across too often, but it does happen sometimes. So for it to be differentiable, first of all, it has to be continuous, and then it can't have any sharp turns or vertical tangents in the graph. So we don't have those things happening here. So it says, there exists a number c in between a and b such that f prime of c equals f of b minus f of a over b minus a. So let's think about the points on this graph right here. If I look right here at a, what's the coordinates of that point? What's my x coordinate? A. What could I call my y coordinate? F of a. All right? So those are the coordinates of that point. And then b over here, the coordinates of that point could be b f of b. Okay, so let's look at this piece right here. F of b minus f of a over b minus a. What is that? That is slope through a f of a and b f of b. If I draw that right here, it's the slope of this green line right here. Okay. Then let's talk about this c that it talks about. So c is a number in AB. So c is a number somewhere here on the x-axis between a and b somewhere. And f prime of c, what is f prime? What does f give us? Slope of the tangent line, right? Slope of the tangent at x equals c. So if I've got slope through the endpoints, right? The slope through the endpoints and the slope of the tangent line are equal to each other, what does it look like on a graph when I have equal slopes? Parallel. We got parallel lines, right? So what I'm looking for, like here, if I want to draw in my C, I'm looking for a spot on that graph right there where I've got a tangent line that would be parallel to my green line. So this would be like a point C. Now there could be more than one. In fact, maybe right here somewhere. I'm not going to do that just because it's going to make my graph look messy. But there could be several points where your slope of your tangent line is parallel. Okay? So we can think of mean value theorem as a place where our slope of our tangent line equals the slope through the endpoints. Now the reason this is called the mean value theorem is because right here we've got the slope through the endpoints could also be called your average rate of change. And that word mean also is another word for average, right? And then this f prime of c, what do we call it? A derivative at a point. It's our instantaneous. Let me use red for that. Instantaneous rate of change. So you have actually sort of already done some mean value problems because I have given you some questions before that ask, where does the instantaneous rate of change of something equal the average rate of change, right? So we've seen a few that were actually sort of mean value theorem problems before you knew about mean value theorem, right? So this next, I've got here it just says, in other words, at some point on the interval, the slope of the tangent line equals the slope of the line through the endpoints, which is what we kind of showed here. So I think that this next one may really help you understand, or at least help you remember mean value theorem. I used to have a different problem here, but we went to Germany on vacation 2 years ago. And for the first half of the trip, we just rode trains and were like in cities. We didn't rent a car. But for the second half of the trip, we rented a car. And about a month after we got back from Germany, we got this letter in the mail. This will be my husband right here, Mr. Billy Bad A right here, driving his car too fast in Germany because they give speeding tickets through cameras in Germany. It was entirely in German. I have, if you're given a function on the interval from 0 to 4, find the C value that satisfies the mean value theorem. So this one's not asking us to prove a mean value theorem. It's saying find the C value that satisfies the mean value theorem. So for the mean value theorem, I need average rate of change to equal instantaneous rate of change. So the first thing I need to do is find my average rate of change. I'm going to use ROC for rate of change. Don't do it on the AP exam, but I'm going to be a little bit lazy here. So if I'm finding average rate of change, I need the points that are in the endpoints. What do I need to do for that? Plug in 0, plug in 4. That'll give me my y coordinates. So if I do f of 0, I will get 0 minus 3 squared, which will be negative 3 squared, which will be 9. So there's one of my endpoints. 0, 9, and then I'll do f of 4. Oh, I should have thought about this, though, first. What condition has to be true for mean value theorem to apply? Continuous and differentiable, right? This is just a quadratic, right? Is it continuous? Is it differentiable? Yes, so mean value theorem will apply here. So if we want the average rate of change, we just have to do slope formula for this. So we got 9 minus 1 over 4 minus 0. And we will get 8 over 4, which is 2. That is our average rate of change. Oh, let's see. 9. Oh, gosh, yeah. Thank you for catching that. It needs to be negative, doesn't it? Let's switch those. We got 0 minus 4. That's a negative 4. Giving us a negative 2 right there. All right. So For the mean value theorem, average rate of change has to equal your instantaneous rate of change. So what do we do to find an instantaneous rate of change? To what? What do we set equal? Not the original, the derivative. Because derivative gives us rate of change of the function, right? So we're going to find the derivative here. So f prime of x, I would use a chain rule here. You're going to get 2 times x minus 3 to the first power. Technically, you're multiplying by the derivative of the inside part, but what is the derivative of x minus 3? It's just 1, so if you leave it off, it's okay here. And so I want to know where this instantaneous rate of change equals the average rate of change, right? That's the question I'm asking. Where does average rate of change equal instantaneous rate of change? Right? Try not to use AROC and IROC on the actual AP exam. Say to yourself in your head, average rate of change as you write those letters down, if you use it. So we would just do 2 times x minus 3 equals negative 2. And so what are we going to do to solve that? Divide by 2. Or you could distribute if you want, doesn't matter, but I'd divide by 2 also. So you got x minus 3 equals negative 1, and then we just have to add the 3. And we get x equals 2. That is, in fact, on our interval from 0 to 4, right? So the c value, they asked for a c value. Your c value is just 2 right there.
What do they have to have it as a c? Why can't it just be another x value?
Mostly just because that's the language they used in the prompt of the question. It's probably one of those things like if you didn't do it on a free response question, they would still count it right. Okay? All right. So what time we got here? Oh, 12 o'clock. We're fine. Okay. We just got 3 questions. They won't take that long to get to. All right. So given that f of x equals 5 minus 4 over x, find all values of c in the open interval 1 to 4 such that f prime of c equals f of 4 minus f of 1 over 4 minus 1. Now, this one didn't say mean value theorem, right? A lot of times this is the way they will present it on the AP exam. But we know it is mean value theorem because f prime of c is your instantaneous rate of change. And f of 4 minus f of 1 over 4 minus 1 is your average rate of change on that interval. Now, let's talk about this real quick. Does mean value theorem even apply? Because this time we don't have a quadratic. Is there anywhere that 5 minus 4 over x is undefined? Like a vertical asymptote. If x equals 0, right? So this is discontinuous at 0, but does it affect us for this problem? It is not, because we're only looking at 1 to 4. Now, if they had said negative 1 to 4, then we could not do the problem, right? So, but it is continuous here. So I just need to do like I did on the last problem. I need to find f of 4, which would be 5 minus 4 over 4. So it'll be 5 minus 1, which will give me 4. So I've got the point 4, 4. And then f of, I don't know why I did 4 first instead of 1, but it doesn't matter which order you do those in. 5 minus 4 over 1. And that would be 5 minus 4, which will give you 1. So we get the point 1, 1. So our average rate of change is going to be 4 minus 1 over 4 minus 1, which will give us 3 over 3, which will give us 1. So, average rate of change has to equal instantaneous rate of change. What do we need to find instantaneous rate of change? derivative. Now, before I take the derivative, I would rewrite this as 5 minus 4x to the negative 1 power, because it will be quicker to take the derivative. We don't have to use the quotient rule if we do it that way. So if I do the derivative of this, what's the derivative of 5? 0. It goes away. Here I'll get 4x to the negative 2, which it will be probably easier to deal with if I make that 4 over x squared. And so, again, we're trying to find the values that make it true like we were on the last problem. So we're going to set these two equal. 4 over x squared equals 1. Can't solve for an x squared while it's in the denominator. Multiply both sides by x squared. So 4 will equal x squared. We will square root both sides. Technically, there you get a plus or minus 2. But should we use both of those answers? We're only looking from 1 to 4, so we just want to say that our C would equal just 2. The answer's not always 2, it just has happened to be for these two problems. Okay, everybody good there? Alright, the table below shows certain values for f, a continuous function. I think that I have made an error on these notes because I can't answer this if it just says continuous function. What do I have to have? I have to have a differentiable function. So let's call it a differentiable function. I need to change those. Okay. Is there an x value on the interval from 0 to 10 such that f prime of x equals 1/2? So if you see a problem like this, the answer is probably yes, right? It's probably a mean value theorem problem because, like, let's say that we do the mean value theorem and we get a no. It doesn't guarantee it's a no at every point here, right? Like because like the slope between 0 and 10 might not be 1/2, but the slope between 0 and something not on here like 6 might be 1/2. So you can't give a conclusive no to this question right here, but you can give a conclusive yes by applying mean value theorem. So in this case, you're kind of having to prove that the mean value theorem applies for this case, right? So since they have said that this function is differentiable, you do need to state that since f is differentiable, f is also continuous. There's times it can be like required to say it. I don't know if it's on mean value theorem here because it. Yeah, it's better to write it. It's better to write it. There's time like intermediate value theorem. You got to say it because it doesn't matter about differentiability, only about continuity for that. I'm not sure. I don't think on a mean value theorem problem there'd be a point for that, but it's safest to always say it. If you see differentiable and you're using one of these theorems, just go ahead and throw it out there because they're not going to count off for it, and it might be something they're checking for. We could say since f is differentiable, f is also continuous. Then we can say that on 0 less than or equal to x less than or equal to 10, the average rate of change and if we're, doing this for test, AP exam, write it out. Average rate of change is, and then I'm going to show your work where you find the slope here. It would be 10 minus 5. Make sure you put your y's on top. And 10 minus 0 here, which is going to give you 5 over 10, which equals 1/2. Thank goodness, right? Because if it doesn't equal 1/2, then you can't prove anything. But most of the time, like I said, most of the time if you see this question, the answer is yes. So on this interval, the average rate of change is 1/2. So by the mean value theorem, and then just restate the question. There must be an x value on the interval 0 less than or equal to x less than or equal to 10, such that f prime of x equals 1/2. Yeah. Just like our intermediate value theorem problems, I'm basically just copying what the question said for that last conclusion right there. You know, there are other ways you can say it. Yes, there are no points for creativity on this test, right? So saying it in a different, fancier way does nothing except for possibly risk that you might get it wrong. So just restate what they're asking for there. Okay. It didn't ask you to actually find the value here, and you can't because you only have a table. All right, we got one more thing to look at. This one's from a graph. The function f is graphed below. What is the average rate of change of f on the interval from 1 to 5? Now, you certainly could actually do a slope formula for this. But right here's 1, and right here's 5. What is your average rate of change? 0. On something like that from a graph, if they wanted you to show the work, it would say something like show the work that leads to your answer. So you'd be okay with just saying 0 right here. How many times on the interval from 1 to 5 does the average rate of change of f equal the instantaneous rate of change of f? Okay? All right, what are the points going to be on this graph? Okay? Right here at 2, 3, 3, 1, and 4, 2. Notice that those are all maximum or minimum points of that graph. Relative maximum or minimum points, most of them. There. So we would have 3 times that happens right there. Now, that will sort of lead into some of the things that we'll be doing next week because a big part of this unit is going to be finding increasing, decreasing, maximums, minimums, all of those things. So, your assignment